Please open in your learning workbook to page 167. We're going to solve some LX problems. Given f and g, find f of g of x and g of f of x. Simplify. Determine whether f and g are inverses of each other. Okay, let's begin with our first problem. So, we need to find f of g of x. Let's do that. F of g of x. We notice that our input is a variable, which means we want to work from the outside in. We're going to start with function f, specifically the right-hand side of function f, but everywhere we see an x, we're going to put g of x instead. So we get 2 times g of x plus 5. Okay, so now we're going to replace g of x with what we know it to be equal to in this particular problem. So we have 2 times this fraction. 2 is the same as 2 over 1, which means this 2 is up in the numerator. This 2 is down in the denominator. So we're going to cancel both of those to the number 1. Anything times 1 is itself. Anything divided by 1 is itself. So this turns into x subtract 5. And then, at the end, plus 5. The minus 5 plus 5 cancel, and we get the result x. Okay. Next, now we got to find g of f of x. All right. Well, my input is a variable, which means I work from the outside in. So I'm going to use function g, specifically the right-hand side of function g. But everywhere I see an x, I'm going to put an f of x instead. So I get f of x minus 5 all divided by 2. We know what f of x equals, so let's replace it. F of x is 2x plus 5. So we'll have this turns into 2x plus 5, then the rest. Subtract 5 over 2. All right, so this plus 5 minus 5 cancels to 0, and then I'm left with 2x divided by 2. This 2 and this 2 cancel to 1, so I get 1x over 1, which is just x. So this is the answer to the first part of the question. This is the answer to the second. Now we just have to determine whether f and g are inverses of each other. That's very easy to do. We've already done all of the hard work. If you compose the two functions together in both directions, and you get the result x both times, then you may conclude that yes, the functions are inverses of each other. So the answer to the third question is yes. Okay, let's change the functions and go through this process again. All right, here we go. F of x equals 4x, g of x equals 4x. Interesting. They're the same function. Let's see if they're inverses of each other. All right, so same process. First, we need to compute f of g of x. The input is a variable, so we work from the outside in. So I need to use function f, specifically the right-hand side, but everywhere I see an x, I need to put g of x instead. All right, so then that's what I'm going to have. Now, replace g of x with what it equals. So I get 4 times 4x. 4 times 4x is 16x. Okay, that's the answer to the first question. Now I need to find what is g of f of x. So I work from the outside in because this is a variable. I'm going to use function g, specifically the right side of function g. But everywhere I see an x, I'm going to put f of x instead. Now for this problem, f of x equals 4x. So I get 4 times 4x, which is 16x. All right, now we draw the final conclusion. Are these functions inverses of each other? The answer is no. We did not get x for both of these results. So, not inverses. All right, one last problem. f of x equals 4 over x, and they are telling us in the problem that x is not allowed to be equal to 0, and that's fine. G of x is equal to negative 4 over x, and once again they're telling us that x is not allowed to be 0 in the problem. Okay, let's proceed. F of g of x. So this is a variable, so we work from the outside in. We start with function f, specifically the right side of function f. So we're going to write this, but in place of the x, we're going to write g of x. All right, now we substitute and simplify. What's g of x for this problem? G of x for this problem is negative 4 over x. All right, so this is an example where we have something where we're dividing a fraction. The 3 words you need to remember when dividing fractions are keep, change, flip. Keep the first part just the way it is, 4. Change the division into multiplication. Flip the bottom fraction over. So this would be an x over a negative 4. Now we know that 4 is the same as 4 over 1. So this 4 and this 4 can cancel, but don't forget about the negative. So this would be a 1, and this would be a negative 1. And then what do we have? 1x over negative 1, which is simply negative x. Okay, let's do the same thing with our next function, g of f of x. So, g of f of x. Our input is a variable, so we work from the outside in, which means we're going to look at the g function, specifically the right side of the g function. We're going to use that, but everywhere we see an x, instead we're going to put f of x. Okay, so now we're going to substitute and simplify. F of x for this problem is 4 over x, so we get negative 4 over 4 over x. We'll keep change flip just like we did a moment ago. So we have negative 4 times x over 4. Negative 4 can be written as negative 4 over 1. Negative 4 divided by 4 is the same as negative 1 over 1. And so I get negative x over 1, which is negative x. All right, so the answer to the first problem was negative x. The answer to the second problem was negative x. The only thing left to decide, are they inverses of each other? The answer is no, they are not inverses. In order for two functions to be inverses, the result we need to get in both of these calculations is x. X. If f of g of x equals x, and g of f of x also equals x, then the two functions f and g are inverses of each other. If either one of these shows up to be not x, then they are not inverses.